Circles part 4, we've got the distance from the center, aka the 4 problem. It was not intentional for me to put that aka the 4 problem with part 4, but it kind of worked out that way, so that's kind of fun. This is a really common type of problem, and there's a theorem that kind of clarifies what's going on. So we're going to go through the theorem first. I'm going to give you an example so you kind of see the structure of the problem. And it starts off this way. Here's the theorem. A diameter meets a chord at right angles if it bisects the chord. Okay. First up, I want you to key in that it says it's if and only if, which means this theorem goes both ways. If you think back to when we did some logic stuff earlier in the year, that basically means the converse is true. So I'm going to go through both directions. The first direction means that I have a diameter that meets a chord at right angles. So that's saying that if I know my diameter meets my chord at right angles, then I know that it bisects the chord, which means I can come over here and say that my chord is now cut into 2 equal pieces. So I want you to follow that logic. If I meet at right angles, then I bisect my chord. That's the forward direction. However, if and only if work both ways. So I can then start by going in the other direction. If my diameter bisects the chord, then it must meet at right angles. And so that means that in my picture, whether I know that I meet at right angles or I know that my chord is bisected, I can make that claim that I've got that diameter. And so we get this fun little give and take where we can go both directions on that. Now this image right here, while it doesn't seem like much, leads to a classic circle problem. And it might be something along these lines. A 16-foot chord is how far from the center if it is in a circle with a radius of 10 feet. Wow. There's a lot going on there, and it kind of makes you wonder how in the world do we approach this. But we're going to take a version of this picture, but I'm going to modify it a little bit. So I'm going to start with a circle. And I'm going to put a center in my circle. And here's what I want you to do. You are going to draw me a 4, but you're going to draw the 4 a very specific way. So follow along. I'm going to start at the bottom of my circle. I go up to my center, and then I'm going to draw the rest of my 4. And here's the reason. I want you to think about this for a second. If I zero in on this picture, I want you to think about the pieces that we have. I now have a radius. I now have a chord. Specifically, I have a chord that's cut into 2 equal pieces. Because this right here is part of a diameter because it's another radius, which means I've got a right angle right there. In addition to the radius and the chord, here's that specific piece I needed, which is the distance from the center. This also checks out because when we think about the distance between 2 points, it has to be the shortest path. And this is the shortest path. I'm going from the center straight to my chord at a right angle, which means if I were to move any direction left or right, I would end up with a longer segment. And guess what? We love right triangles. Pythagorean theorem, trig, we got all sorts of options there. The key though, distance from the center is code for make me a 4 problem. Okay, so let's draw a new circle and let's approach this problem that we were given right here. So I'm going to come over. I'm going to draw a new circle. Got to put some numbers on it, so I'm going to make it a little bigger. Let's break it down. 16-foot chord. Now I've got a 16-foot chord, but I also know that my chord gets cut in 2. So I'm going to go ahead and mark it as 8 and 8. Okay. I want to know how far from the center of the circle. I know that that center is right here, and so I'm x units away. And then I know that I've got a radius of 10 feet. Well, sure enough, my picture has a radius right here. I've got a 10. And guess what? Because I know this, the way this problem is set up, this right here is a right angle, and I can use Pythagorean theorem, I can use triples, I've got all sorts of options. So if you needed to use Pythagorean theorem, you might already recognize this as a triple looking at this picture, but if you need to use Pythagorean theorem, we've got leg squared plus leg squared equals hypotenuse squared, which means I've got 8 squared plus x squared equals 10 squared, 64 plus x squared equals 100, x squared equals 36, which means x is 6. Okay? The idea being, distance from the center is your key words for make a 4 problem. Distance from the center, you're going to make a 4 problem. And be careful about how you draw it. Make sure that the top of your 4 is at the center. Some people try and draw it all the way at the top and come down and across and they get super confused. You do need to draw the 4 a specific way, but keep that in mind.